Hello, all. Welcome back to my channel. So far, we have seen machine learning models, the way how we train the model using the random forest classifier, which is one of the most effective and efficient model that I have seen so far. And why we always have to use the random forest classifier? Let's take a look at the linear SVC as well. So, linear stands for the linear data. I mean, when your x value is increasing, if the y value is increasing or decreasing, if there's a characteristic like that, we call it as a linear. And SVC stands for support vector classifier. Okay, let's deep dive into this one. Let's see. So I'm going to use a different. Okay, the same here. So linear SVC. Okay, so let's do everything from beginning. Let's import the data. Import pandas spd. Df is equal to pd dot read csv. Low memory is equal to false. I want to use all the cores here, cpu cores. Df dot head. So we already did the data exploit analysis for this one. So let's quickly check what the values here. And these are like ones and zeros, which means that we have to use the classification model. Okay, let's the output is the target one. So x is equal to df dot drop. So columns. So for the x1, what I'm going to do, other than target, everything comes under the x, and the y is the target. Df dot drop columns is equal to, I want to drop this column. Axis is equal to 1, which represents the columns. I mean, this is in the columns wise. Y is equal to df of target. Okay, so if you see x value, always check, guys, always check the data. Okay, let's split the data from sklearn dot model selection. Import train test split. Next, import numpy as np dot random dot seed 42. I'm going a little fast. I'm sure by this time you know what's the reason, because we already have covered all of this earlier. X train, X test, Y train, Y test is equal to train test split X Y. So if you notice, we are writing the same again and again and again. That's the reason I usually tell to everyone that ML is easy if you have a proper guidance. State is equal to 42. Stratify is equal to y. Okay, the stratify is equal to y. It only works for the classification data. Okay, let's do this one. X train dot shape, y train dot shape. Okay, x test dot shape, y test dot shape. This is fine. I'm to 42, 42, 61, 61. This value should match, guys. So now train ML model. So I'm going to develop use this one from sklearn dot svm import linear svc. Okay, if you go to my first video here, you can see the linear svc here, right? See, so that's the reason if you buy heart all of these models, like practice, 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 then it's very easy for you, like how to quickly get what model you have to get when we say like use that model or this model. So I'm going to name this svc is equal to linear svc, and we know what to do. Svc dot fit x train, y train. That's it, guys. We are done with one more model, linear SVC. So SVC dot score. Let's see the score on test data. Y train. Okay. But if you remember the random forest which we trained earlier, X train, comma Y train. hmm, This random forest is like 100 percentage, whereas this SVC score is like 84 percentage. Okay, that is totally fine. Let's take a look at SVC dot this linear SVC X test, Y test. This is like 80 percentage, guys. And let's remember RF dot score X test, Y test. Okay. So let's quickly a plot graph. Okay. For example, RF random forest test score is equal to RF dot score X test, Y test. Okay. SVC test score is equal to SVC dot score x test y test. Okay, so import matplotlib.pyplot as plt plot. So rf test score SVC test score plot dot show. Let's take a look at like how this looking like. Okay, why this one? This is a value np dot array. This one here. I hope it should work, or else this will be bad. I would like to plot this one, and this is not happening. Oh, 0.83. No, 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 no. So, no, no, no. Okay, sorry guys. So what we will do, I will try to find another way. So we have both the scores here, right? So what we can do, pd dot data frame and data is equal to. If you're not comfortable with the pandas, how to use the pandas, do let me know in the comments. I will do a video. I mean, like some 2 to 3 hours of video, which helps. So because they has like constant values, we have to. I mean, if you run this one, it will show like if using all scalar values like one values, you must pass an index. What is one value? For example, if you print this value, this is like one value, right? So what we are printing, index is equal to accuracies. So this is like fine. So rf random, using the random forest we achieve like 83 percentage, and using the svc score svc it is like only 80 percentage. So let's plot this one. Kind is equal to bar plot. Okay, this is not. So let's transpose this and let's plot. So this one, okay, totally fine. um, Location is equal to this works. Okay, this is not happening here. Okay, kind is equal to bar, and label is equal to false. I am not sure guys, I'm just trying experimenting. Okay, if you see here, rf this random forest, here the accuracy is more and this one is accuracy is less. So I mean, by doing like something like this, we can assume that okay, rf is the best, random forest classifier is the best one for this model, for this data set, whereas for the linear svc it is performing, its accuracy is little less. So, in the upcoming next video, we will take a look at logistic regression as well. Why not? Let's also try with this one. I mean, that's all for this video, guys. Thank you for watching. Have a good day.